Hey everyone, welcome to Hacking IIS with Shubs. I just want to start off by saying how much I enjoy hacking IIS servers. They're case insensitive, which means that you can usually find content very easily as you don't have to worry about the case. You can use IIS short name scanner, which lets you determine partial file names and folder names. There's something called the view state deserialization RCE gadget, which lets you achieve RCE by providing a malicious view state that's been signed with the machine key. And there's also the web.config upload tricks, which usually let you get a shell in tricky situations. On top of that, you've got debug mode, sometimes enabled on .NET applications, which give you detailed stack traces and full paths, which are especially useful for uploading shells. And there's debugging scripts often deployed, such as Elmer and Trace, which often give you session tokens or cookies that you can use to escalate privileges. And lastly, there is something called the Telerik RCE, which is a compilation of maybe 4 or 5 CVEs over the last couple of years, which usually lead to RCE. Most recently, a deserialization exploit in Telerik that led to RCE, but in the past there was also arbitrary file upload vulnerabilities through weak cryptography. So the first thing I want to go through today is how you deal with HTTP API 2.0 assets. When you've been hacking IIS, you might have come across something like this, where you visit an IP address and it returns a not found error, HTTP error 404. And in this scenario, you can see that the server header returns Microsoft HTTP API 2.0. Now, you might look at this and you might think, okay, there's no way to access a real application on this host. But that's actually not true, and it just requires a little bit of more work and investigation to be able to access a real .NET application on these sort of hosts. So in this scenario, you can see in the screenshot that I've provided that there's actually an SSL certificate which has the subdomain listed in the common names for the certificate. This is really handy. I'm not saying that this is going to happen all the time when you attack IIS servers, but if you do find an SSL certificate with a subdomain, that should be the first piece of information you use when you try and make this web server respond with an actual application instead of this HTTP API 2.0 error. Once you've identified there's something like a subdomain in the SSL certificate, you might want to try the following. You might want to think about not skipping the asset first off and actually thinking about, okay, how do I access this application? And you know, sometimes you're not fortunate enough to have access to the full subdomain provided to you via the SSL certificate, so you might need to brute force it. However, it's as simple as modifying the host header. So you can see in these two requests, the first request, there's a 404 not found error with the HTTP API 2.0 server header, which means that there's no application really responding, and that's when I'm accessing the application directly via the IP address. But you can see in the second request, I've modified the host header to contain the data that I obtained from the SSL certificate, the host name. So really what this HTTP API 2.0 error is like, it's just telling you that it can't access the virtual host, or it can't access a real application on the IIS server. So when you provide a host header with the virtual host that it's expecting, it actually routes you to a valid application. So you can see in the response in the second request, it's turned from a 404 into a 403, and you can see that the server header has changed from HTTP API to Microsoft IIS 8.5. In many cases, you'll find that the subdomain you find from the SSL certificate doesn't actually resolve to an IP address that you can access. So in this scenario, it's really important that you just add a line to your etc host file and you map the correct host name to the IP address of the asset. So in this scenario, I found a subdomain called icc.company.com. I would put an addition to my host file, which maps that subdomain to the IP address identified through whatever means. And once you've done that, you should run all of your scanning again, including your enumeration through IIS short name scanner. It's incredibly important to run all of your scanning again because you're basically scanning a valid application, whereas with HTTP API 2.0, you were scanning nothing. The other thing you can do in this scenario is also perform vhost enumeration and brute forcing to see if there's any other applications that are present on the host. you'll be surprised sometimes that there are other applications lingering around. You just need to know the correct host name so that you can access them through IIS. If you ever come across this for other assets, just repeat this methodology, try and guess the vhost, and then provide it in the host header in order to access the real application. So moving on, I want to talk a little bit about vhost hopping. This is something that I've been pretty successful with in bug bounties. One example I can give you is I was able to access an internal admin panel via vhost hopping. They paid out $1,900. So I came across an asset that looked something like apply.company.com. It was running IIS, and at that point I was quite curious to see if I could find any other virtual hosts for this asset. So I used a large subdomain word list to brute force the vhosts using burp intruder. So you can see in this example, this is kind of the area I brute forced, just subdomain.company.com, and I was brute forcing the subdomain. And I looked at any large and different responses returned, and I found mssql.company.com, which was not accessible externally. It was only accessible through vhost hopping. And at the end of the day, when I looked at this particular vhost accessed through this IP address, I found out that it was running a MSSQL database manager / explorer, a link to the SourceForge project which contains that explorer. And often on IIS servers, there may be internal applications running under a different host name. For example, in this case, it was MSSQL. There could be other applications running as well, but I may have not have brute forced the subdomain. However, it is something that I recommend you do every time you come across an IIS asset that may contain more than one application. I guess building up that instinct is really important, and understanding when to do these sort of brute forces is very important too. Usually every time I do come across an IIS server that looks like a development or a test server, I run a hostname brute force to see whether or not there are any other virtual hosts for that domain. So in this example, I just added a simple match and replace rule in burp that replaced any host header which had apply.company.com with the host header mssql.company.com. And in return, when I visited the subdomain, you can see that it prompted me with this ASP.NET Enterprise Manager. Now, this was really interesting, and I played around with it a little bit, got access to the post-authentication part of the application, and reported the vulnerability. As I said, I got paid $1,900 for this bug. Next thing I want to go through is local file disclosure to DLLs. So you can take this example of code, which is written in C#, which is a basic local file disclosure vulnerability. You can see that there's an endpoint called download category XL, and this endpoint takes a file name as a parameter, and it builds a path using the file name as the parameter, which is vulnerable to directory traversal and arbitrary file read. So you can exploit this endpoint and provide a file name which traverses back to directories and reads arbitrary files from the document root. So that's essentially this vulnerability here will let you read local files from the system. So in this scenario, what do you do? Well, I guess the first thing to look at is the web.config file. Web.config is your friend here because it will tell you what the other files you need to grab from the system are. You can follow this resource that I've linked here, which is from path traversal to source code in ASP.NET MVC applications. It's a very handy resource. I've used it multiple times in bug bounties. It helps you quite a bit in understanding how the web.config file and global.asax file actually provides this sort of information, and you can read through it to understand how you can exploit this vulnerability. But to kind of give you a TLDR, you grab the web.config file and you grab the global.asax file, and inside them you'll see references to DLL files. So for example, you can see here add namespace company.web.api.dll. Now this is really important. You need to get this DLL file name, and then you can download it from the bin folder. So you can use the same vulnerability, the local file disclosure vulnerability, to download the DLL file from the ASP.NET MVC application. Once you've done that, you can do a wide range of things, such as reverse engineer the DLL file and even debug it if you really want to. But it opens up a lot of possibilities in finding further vulnerabilities in your target. You should repeat this process for all other DLL files that you think are worth grabbing, but often this will be a really effective way to show impact that, look, through the local file disclosure vulnerability, I can read all of the source code for this application and potentially find more vulnerabilities within the application. Another really cool technique in IIS is local file disclosure to RCE. And this is something that's only relatively recent research-wise. It was nominated for the Pawnee Award for Most Underhyped Research. And you can read these two links. One is the blog post from Surosh, and the second is the white paper from him as well. So these two resources are absolutely gold, and they will give you all the information you need to understand this vulnerability. But essentially what you can do on IIS servers is, if you can read the web.config file, you can almost always get RCE, which is insane. Like, I can't think of other web servers where having one vulnerability leads to a more severe vulnerability reliably, which is also one of the reasons I love hacking IIS. And you can see here that, from my experience, it's a very simple process. You grab the machine key variable from the web.config file, which includes the validation key and the decryption key. And then you can use a tool such as ViewGen, made by Andre, or ysoserial.net, and you can exploit the view state parameter so that you can sign a arbitrary view state which is malicious, and you can ultimately end up at the sink of object state formatter, which is vulnerable to deserialization, and from there you can get RCE. So I really recommend you read the blog post and the white paper. It does go into much more detail about how this works. But essentially, if you have local file disclosure and you can read the web.config file, it's quite likely that you can get remote command execution. The other thing that I think is really important to know when you're hacking IIS applications is using dnSpy. dnSpy is an open source project. You can grab it from GitHub. But let's say in this example, you were targeting a dependency. You were trying to brute force a .NET server and you came across this folder called Qtsoft client, Qt editor uploader.ashx. Now you might be wondering, are there any vulnerabilities in this uploader.ashx file? Well, that's really easy to solve. You can download these dependencies usually from the internet using NuGet or either directly from the vendor's website. And once you've downloaded that, once you've downloaded that package, it might contain DLL files, but sometimes it won't contain source code. And usually to find vulnerabilities, you want to be able to read the source code so that you can see whether or not there are any vulnerable components. This is where dnSpy comes in, and it helps you analyze the source code and potentially find vulnerabilities. It reverse engineers DLL files back into the source code. So you can grab dnSpy from this GitHub link here, and it's capable of reversing assemblies, DLL files, back into source code. You can simply load the DLL file and export the source code project. So here is a screenshot of me loading a DLL file, qteditor.dll, and then here's how you export it into a project that you can then read with whatever editor you want, or you can even load it up in VS 2010. You can also alternatively navigate through dnSpy itself. It's actually pretty handy. It has some great searching functionality. It also has live debugging functionality, which you can dive into if you're having trouble understanding how the application operates and you want a more live environment to investigate vulnerabilities. The next thing I want to talk about is complex XXE vectors. Now, this is something I deal with often on some bounties that run .NET servers. Let's say we have this scenario. There's no outbound HTTP traffic allowed. The only outbound traffic possible is DNS. Your external entity is not being displayed in the response anywhere. You cannot use external DTDs because you cannot reach your external host via HTTP. However, luckily, we have stack traces enabled, and that is the only real thing that we have towards exploiting the XXE vulnerability. without any outbound traffic other than DNS, it's very hard to prove impact. So what do you really do in this scenario? Well, the typical research that you can find on the internet is around exploiting XXEs with local DTD files. And you can see an example here of that, where we are including a local DTD file that's always found on Windows systems, which is cim20.dtd in the system32 folders. And then we are declaring our entity file system Windows system.ini, and we're trying to leak that file out via an error message by requesting a non-existent file and appending the file we've retrieved to the end of it. However, what can often happen in this scenario is you can find that the XML parser might actually not respond with the data of the file. You can see here that, we've got our local DTD, we've got our local file to read, and we've got the side channel leak. However, when you run it through, when you run that request, you can see that the response might be something like this, where it says an error occurred while passing entity name, line 37, position 46. So it is reading some sort of data, but it's not giving that data back to you. The error message does not contain the contents of the file. In that scenario, this is how I've been able to deal with it. Thankfully, in this scenario where there's no data and there's a passing error, there is a solution. Huge thank you to Robert Vulpe on Twitter for this trick. His Twitter handle is @nitrogen. To break this payload down, you've got a hash after the non-existent file, so that the file entity is a part of a fragment identifier. That's the only main difference between the previous XXE payload I showed you and this one. In this payload, the side channel leak happens because of this fragment identifier. After the file is included after this fragment identifier, you get a wildly different message in return from the stack trace, which contains the partial contents of the file. So you can see here that the error that we get back is fragment identifier and then the file's contents. So the fragment identifier error and then the file's contents. At least the partial file contents. You can see that it gets cut off at some point, so it's not something that will give you the full file contents, but at the same time, it does prove impact and it does let you access some of the file contents before being cut off. Another thing that I want to go through is partial fuzzing with short names. Like if you've ever watched any of my videos on IIS short name scanner, this might be relevant to you. You might want to run short name enumeration on any IIS target you come across, and you might see something like this. In this example, you can see that we've got a couple of folders that have been detected, but not the full folder name has been detected, just a partial folder name, as IIS short name scanner does. You can see that these folders are named lids DI, lids SE, lids TE, and then easy FI. Now, all I want to introduce to you today is just logical brute forcing. You just want to logically fuzz things so that you can detect what the full folder name is. And, often people think they need to do pure brute forcing, like brute forcing all the characters for 4 characters or 5 characters, but sometimes it can be a lot more simple than that. And in this example, that's kind of what I want to demonstrate. If you were using something like ffuff, you can see here that I have transformed these partial folder names into what I would typically be putting into ffuff. You can see that there's lids DI, which has been converted to lids fuzz, because I believe that the partial name of the folder is lids, and then there's something after that that could be something we could discover. And the same goes for lids SE. The pattern between the first two is that they both start with the word LIDS, with the letters LIDS. So I'm going to fuzz everything after those 4 letters. And then you can also see easy FI, and that's just going to become easy fuzz. So my typical ffuff command might look something like this, where I am fuzzing the remaining characters, and I'm using a prefix, which is LIDS, because I believe that's the common prefix. And that actually leads to some really great results. you can see here that we've detected that the full folder names are lids test, lids display, and lids service. So it doesn't really require you to do pure brute forcing or some crazy technique. It just requires you to logically think about what is the partial folder name and how can I brute force the rest of it, which is kind of what I've done here for this host. Another tool that you should check out is Crunch. If you're ever in the situation where you need to do some pure brute forcing to determine the rest of the file or folder name, you can use Crunch to generate the word list that may be necessary to pass into FFuff to discover the rest of the file or folder name. You can provide it an arbitrary character set. In this example, I've done all lowercase letters and numbers, and I'm making a word list which is from 0 to 3 length, and that generates roughly 47,000 lines, and then you can use that with FFuff. The link that's at the bottom of this slide just links to the SourceForge project, which you can compile on any Linux machine and start using this tool for brute forcing purposes. And I'd just like to end this presentation off with some more resources on hacking IIS. We have a YouTube channel, Asset Node's YouTube channel, which does have videos on hacking IIS, but will likely contain videos on all sorts of different hacking adventures that we do throughout our time working at Asset Node. On top of that, I really love the blog from Sarosh. He is absolutely outstanding at hacking IIS servers and ASP.NET applications. He's gone through many techniques, many more than I can actually discuss in a video like this. So I highly recommend you check out his blog and you read through some of his articles that he's posted on the internet. And lastly, there's also BitQuark. He has done an amazing job at building an IIS short name scanner. He's planning to release it to the world at some point. He's still working hard on it, and he's still doing an amazing job at building it out. I've had the privilege of using it over the last couple of weeks, and it has been really a game changer when it comes to IIS short name enumeration. And lastly, Nitrogen, who discovered the technique for XXE in order to leak partial file contents via fragment identifier errors. Thanks everyone for watching this presentation. I really appreciate your support.